Okay, hello, my name is Freddie, and in this presentation, I will discuss the role of friction in rock climbing. So the rock climbing is essentially a tug-of-war between the friction force and gravity. The climber must generate enough friction force to resist the gravitational pull of the earth. There are many different factors that influence the friction in rock climbing, such as rock type and structure, moisture, the material of the shoe soles, finger and hand position. So in this short presentation, I will specifically discuss the rock types and its role in friction. So factors that affect rock's friction coefficient are grain size and shape, sorting and porosity, and composition and cementedness. Grain size refers to the physical dimension of individual particles of rock. Rougher rock surface will generally provide better friction than smoother surface, but only up to a point. If the grain size is so big that the surface shapes become irregular, the rubber soles of climbing shoes and the skin of climbers' hands cannot adapt properly to its shape, and therefore it reduces the true contact surface between the climber and the rock. Sharp grains will have higher friction than the round ones. How the rock was weathered, i.e. by wind, rain, or glaciers, etc., will influence the grain shape. Well-sorted materials are composed of grains of approximately same size, and they tend to have higher porosity than the poorly sorted materials. Poorly sorted materials have smaller particles that fill the gaps between larger particles. Gritstone, for example, is poorly sorted with grains ranging from sand to pebble. Sandstone is well sorted. Sorting ultimately affects the porosity of the rock. Well-sorted rocks and rocks with greater porosity provides greater friction due to greater surface area. Some other factors include composition and cementedness of the rock. Composition refers to the relative amount of chemical components in the rocks that will influence friction. Well-cemented rocks are well held together. Certain types of granite and sandstone aren't. So when they are climbed on, the grains break off and act like ball bearings. And that greatly reduces the surface friction. At this point, I would like to address something. We have learned that friction depends on the material and the force, and is independent of the contact area. So to the naked eye, friction force is independent of contact area as long as the applied force remains the same. So in this theory, when two materials are in contact, it is actually the peaks of its roughness, known as asperities, that actually touch. So the true contact area is less than the apparent contact area. The picture here demonstrates how the true contact area remains safe whether you position the brick on its short side or the long side. This theory of friction applies to two relatively flat, even, smooth surfaces that are parallel to each other. However, this definition of friction does not consider one hard and irregular surface, such as rock, pressing into soft, supple surface, such as rubber or skin. This means that for rock-rubber or rock-skin interaction, the apparent and true contact area are in fact directly proportional, and hence the friction is proportional to the contact area. Well, in conclusion, friction is one of many things climbers must consider when climbing, but it is one of the most important. And having better knowledge of friction will inform climbers in their decision making. When a climber makes informed choices, they can climb safer and more effective. And here are my references. Thank you.